Hi, my name is David from Electric Teaching, and this is part 5 of my quadratic program with Python and Pygame. As you can see, we do have a window now called Screen from our Pygame library, established from our Pygame library, and we have put the graph paper on it, and we have displayed some answers about the quadratic equation in question. I ran a 1x squared 5x plus 1 here, and have symmetry line vertex and some x-intercepts. Our goal now is to get the X and Y grid on there as well as the graph in the next couple parts here. Let's close the window and let's start adding some more code. Down here in our graph equation, right under where we've put in the code for drawing the graph paper, let's have let's draw the X and Y axes. Let's draw the X and Y axes on our screen. Okay, and to do this, we're going to make some new variables. I'm going to make a new variable called mid-x, and that's going to be the width divided by, I'm going to use some extra parentheses here because of the numerator, the width divided by k. That's in case 16 in this at this moment. And then we're going to cut that in half, divide by 2. I could actually just divide by 2k directly, but I'm trying to illustrate the point of what we're doing more than just simplify the math equations. I apologize out there for anybody like me who likes the simplified math version. Over here we're going to do the same thing. I've copied and pasted it, but made a mid-y. And now we have the height. So we have two new variables here to get our x and y axes. We are going to draw two big lines using Pygame library. Draw section, and this, just like before, we're going to draw a line. It's going to be onto the screen. I want it to be black, so in this case I want to let all the red, all the blue, all the green through, RGB, okay, all the red, green, and blue through. And when you let all the light through and put all that light on and try to shine a flashlight through, it lets absolutely all the light through, which then will turn it all to black. So I hope that makes sense. Everything's a little bit backwards when it comes to the graphics on the screen, including also the y coordinates as we learned in the last video lesson. Okay, we're going to draw a line at mid x times k. Mid-x times k, comma, 0. Mid-x times k, comma, 0. Okay. To mid-x times k, star k, comma, height. Okay, so this is drawing from the mid-x coordinate, and that's mid-x, so that's 8 times k. So that is, and you might think I could just take the width and divide it by 2 here. I'm going to explain why I'm not doing that, okay? Because if somebody's following along, I've divided by k and multiplied by k, which are a little bit odd. But what we're doing here is we're trying to make sure no matter what the k is, that this thing is locked down on one of the grids and not dependent upon the screen. And so I've done this in a way to kind of round the numbers as it keeps plugging and chugging. So for whatever reason, if width divided by k was a rational number that was not an integer, basically, what this does is this keeps everything on the grid. I'll show you that, explain that a little bit more in a minute here. Finish this off, so I'm drawing from, let's say in this case, that's 8 times 25, or 200, half the width, over to the right, comma, 0, no height change, and then down to the same x coordinate, so 200, then down 400. And again, that's an upside down screen. We're going to put a 3 pixel wide line there. So again, I'm going to show you my drawing guide here. So what we're drawing now is we're drawing this vertical line. We're coming over 8 times 25. So of the 400 pixels across, it is going over 200 pixels, which will put us on the mid-graphing grid line. And I know this is excessive, but what I want is to be able to make my grid size different at any time I wish. And I think that's important which then requires me to use lots of variables and variable notation. But I think it's important to do this to give us the ability to change our grid size at any time. Okay, and I'll exemplify that hopefully when we get done with this part here. Let's put in the horizontal. Pygame, draw, line, screen. Again, black. That. Comma. Now we're going to do from 0, comma, down 200 pixels. Down 200 pixels is our mid y, 8 times k of 25. Again, using variables here to control. Let's see, to the point width all the way to the width. So we're drawing the horizontal, so we need to go 400 pixels across. So there's your 400 pixels across. Okay, but again, we're going to make sure we're on the correct y line, so mid y star k again, mid y star k again, and 3 pixels wide, 3 pixels wide. So now we have a axis grid, a black axis grid. Okay, and it is 0, 0, 0, so it has no color being let through. I think I said that backwards in a previous one. I get this backwards all the time. I apologize. So it has no color, so when you shine a light through, it has just the black screen, and where this one up here where we filled it with white, I think I said it backwards way a long time ago, when you try to light it up, it leaves the white screen. It's hard to explain. It's just got a backwards feel. I apologize for my lack of ability of describing that clearly. Let's run it. It's going to ask me to save it because I haven't saved it. Let's give it in the equation. Okay, and bingo, we have a grid with black axes on them. Boy, I hope yours work too. And to really make sure yours is working accordingly, again, I could have used minimal variables here, but I feel it wouldn't have been as interesting or dynamic as in maybe putting 15 here. So 15 pixels, tiny grid. All I change is the K. That's all I do. Change the K to 15. Now let's see what happens. I'm going to put in a 1, 1, 1. And now you can see I've got a perfect grid. Well, I should not say perfect. You get the idea here. Got one line off over here I've missed. So you can see I need to do some adjusting to make this a fully dynamic one. But at least the black axes are right on the midpoint, and when we start to graph, we'll know exactly this is on a graphing idea, 0, 0 point. Okay, so I'm going to switch this back here to our 25 to keep it consistent for learning purposes. Okay, and let's start trying to draw the parabola. Okay, where are we? We are right here where we've drawn the grid, the x and y axes. So now let's graph the parabola of the equation. Okay, and we're going to do this across the width. We're going to think about this as plotting it across the width. We're actually going to be plotting it across the width. Okay, as in the width is our x coordinate as we're putting it in, and we're going to get a y coordinate and then plot those. Okay, and it gets a little complicated because of our screen, and that's why I have that guide. We're going to do this with a for loop. Okay, I want to do this. I want to make as many dots as I can. So I'm going to do this for I in range of the entire width. So I want to do this from 0 to 399 in this case. That's a 400 iterations. 0 to 399. Again, for loop start at 0 and go as many as you want them to go to. So 0 to 399 is 400 iterations. So I'm going to make 400 dots on the screen. At least I'm hoping to. Okay. I am going to first do this by making a x and y location. I need a new variable, x. It's equal to, okay, and this gets a little complicated, go with me. I'm going to plot this from on the right dot first. I'm going to plot this on the far right first. So the width, okay, divided by 2. The width divided by 2, okay, divided by k, so there's that 16 again, minus excuse me, I mean width divided by 2 there, width divided by 2, and then I'm going to subtract off the I iteration that we're at. So that'll start us off at the 200 point. That's the middle of the screen. So I'm going to start us off at the middle of the screen. I'm going to subtract off the I here. And then what I'm going to do is I'm going to divide this value by k, but not just k, by the rational version of k. K right now is an integer 25, and I need it to be 25.0. When I make it 25.0, and I could literally put, again, 25.0 right there, but what I want to do is I want to keep k being a variable, so I don't want to just put the number 25.0. What I want to do is have the float command, which changes an integer to a rational by basically just putting a 0.0 on it, making it in decimal form in a sense. So that way it can have long, um, uh, um, decimal numbers to get accuracy in my plot here. So this is going to be basically right now, my x value is going to be 200 minus 0 at first, okay, divided by k, which is 25. So it's going to be my x value of 8 right here. I'm going to do this. The y value is very simple. Y value is very simple. It is going to be the a value, the a star, the x value above that I've just calculated squared. And to square something in Python, you do 2 stars, not a caret like you do in a lot of other coding. So 2 stars, and then you go plus b times x, and now plus c. So this is basically plugging and chugging, as I tell my students, plugging and chugging our x value into our y equal ax squared plus bx plus c equation. Okay. But at this moment, since I'm using a, b, and c, and I'm in a program that doesn't know, no, excuse me, I'm in a function that doesn't know a, b, and c, I have to global a, b, and c, or pass it to this function, one or two. To make this simple, I'm just going to global the functions a, b, the variables a, b, and c. This font command, I forgot to move that as well. If you did not move that out the last time, that also wants to be out in the main area so that I can use that variable everywhere. Okay, back inside where I've defined my main, I need to global some variables here. So first comment, global variables being used in other functions. Okay, and again, I could pass that, but I'm going to leave that for another lesson. I'm going to make this as simple as I can be and use a command called global a, comma, b, comma, c. And it's very important you put that in front of the a, b, and c the first time you call it out or you assign it. Okay, so again, let's scroll back down. Now, back in my graph equation program, you can see now a, b, and c will be understood. And now I have the y value. Okay, so let's now make I'm going to make a new variable called position. A new variable called position. Position. So I'm going to call this position 1. Later I'm going to have position 2. Right now, so I'm going to call it pos1. I'm making up the variable name myself. It's not a command inside Python or Pygame. And I'm going to have brackets, meaning there are 2 parameters, 2 attributes, 2 parts of this variable. So brackets meaning there are 2 parts here. Width divided by 2, okay, plus x times k. Now, what that means is that I've got to take the x-coordinate of 8 and retranslate it to be back on the screen at the 400 point of the pixels across. To make sure this is understood, let me finish this. When I get done with this, I will go back to my drawing and make sense of this. Okay? But right now, let's just type it in. A lot of times when we learn code, we type it in, not exactly knowing how it's going to work. A lot of times, if it's going to work. But we still want to follow along, type it in, and then come back and try to understand it or gain a better understanding of it later. Okay, I've been typing in my y coordinate, same idea, starting at the 200 point, but to go up is to go minus in the y coordinate because our y coordinates are upside down compared to traditional math. Okay, So these are the two different things that I'm putting into position 1 or pos 1. Okay. Now I'm going to draw it. Pygame. I'm going to draw circles in this case, not a line. I'm going to draw circles. So I'm going to draw Pygame. Okay, circle command, same as the line command, same as the line command, or the line routine that they have in Pygame's draw library. We are going to tell it to the screen. We are going to tell a color. So again, I'm going to pick a color here. I'm going to pick, how about just red? So we'll go 255, all red. No green, no blue. So when a light shines through it, it's just all red on the screen. Then what we're going to do is have the position of the center of the circle. Well, that's my pos1 variable. That's why I made that variable. Makes it convenient. And how many pixels wide? I think we'll do it for 3 pixels wide here. So we'll make circles of 3 pixels radius, basically. Excuse me, 6 pixels wide, if you want to say that. So that's how it makes circles. It's going to do this how many times? Width times. So 400 times. I should get 400 circles on our screen. Let's run this and see if this works. Okay, off the screen. I'm sorry, it's off your screen, but down below here, I've got a lot of things going on. Let me close this window here. Try running it again here. So let's run it one more time so we can see a fresh screen. There we go. Couldn't see my shell. Let's do a 1, 4, 1. And there you go. You have dots on the screen that represent our parabola being drawn. The parabola states over here in the shell that the vertex is at -2, -3 with the one we've inputted. And if you look, you go -2, down 3, and you can see the vertex is clearly there. The x-intercepts are rational, and they look to be right on as well. And the symmetry line at -2. So one other thing I like to do, I know we've gone over my 15-minute mark, hang in there, close the window. Let's finish this off by drawing a line instead of circles. I'm going to keep the circle command in there. Okay, keep the circle command in there. I'm going to comment this part out. Okay, in case we want to leave it for later, maybe even make it an option that you can do. We need to make new x's, so we need to draw from point 1 to point 2 when we draw a line. So pos 1 will be point 1. I'm going to make a pos 2 with 2 new x and y's, or a new x and a new y. And the same idea as the old one, I'm going to take the width divided by 2, but to be at the next location, all I have to do is use I plus 1, so that I'm 1 pixel off on my location. Again, divide accordingly. So I'm going to go, close parenthesis above, divide by float k, divide by float k. So my next x coordinate, and thus my next y coordinate, I'm going to copy this guy and use that. My next y coordinate, which is ny, my next x, which is nx, my next y, ny uses the nx, and now I have that. I'm going to copy the pos 1, copy, pos 1, paste, call it pos 2. Pos 2 will not use x, it will use nx, and it will not use y, it will use ny. Now we've got a second position that is the next one over. We're going to draw a line from this point, Pygame, draw, line, screen, again red, so the same, 255, comma 0, comma 0, comma, from pos 1 to pos 2 of 3 pixels big. Save and run. Let's see how it works. Let's put in the same one, 1, 4, 1. And again, you have not dots, but what I see is almost a smoother connected line. Your choice, whichever way you like to do. I'm David from Electric Teaching, and I've gone well past my usual 15-minute limit that I like to keep. I hope you've enjoyed this, and I'm going to do some more and add a little bit more to this if you continue on with this video sequence. Thank you for listening.